everyone. In this video, I'm going to explain quantum physics part 4. In this part, we talk about de Broglie wavelength. What do you mean by de Broglie wavelength? Any particle of momentum B should have a wavelength. So any particle moves, act as a wave, has wavelength. The wavelength or de Broglie wavelength equals h over b. B is the momentum, equals mv. So lambda equals h over mv. M is the mass in kilogram and v is the velocity meter per second and h is Planck constant. The relation between the momentum and wavelength is inverse relation. So this is the graph. Remember, for photons, always we use Planck's equation, E equals hf. So the wave acts as a particle because it has energy. For the wave behavior of subatomic particles like electrons, always we use de Broglie equation, lambda equals h over b. So any particle acts as a wave. So this is a dual property of anything. So the wave acts as a particle and the particle acts as a wave.
In order to try and model what we observe, sometimes the wave model seems to work. And this explains things like refraction and interference. But other times we need to think about using the particle model to explain what's going on. And this might be, for example, where we had the photoelectric effect. And so far, what we've looked at is maybe the wave having certain properties which then give particle-like properties as well. So we said E equals hf, or we can look at how the frequency of that wave gives certain photons a certain energy. Now, if a wave can behave as a particle, then surely a particle can also behave like a wave. And this is where this wave-particle duality comes into force. And it was about in 1924 when a scientist was sort of finishing off his work, and as he put his thesis forward, he talked about the wave-like property of certain particles. And his name was Louie Dubrow. Just be aware that his name is pronounced Broglie, not Broglie. Okay, and what he said was that there's for any particle that has momentum, p, it also has a corresponding wavelength. And there's some link between the momentum of the particle, which we give the symbol little p2, and the wavelength. And what he said was that the wavelength of the particle is equal to Planck's constant divided by the momentum. Or we can write this as h over mv. Now the important thing here is that this m here is the relativistic mass of a particle. This means as a particle gets closer to the speed of light, the mass tends to increase due to relativistic effects.
Now you can solve it, try by yourself 10 in future in physics book. He said electrons, the mass of electron is 9.1 times 10 power negative 31 kilogram. Accelerated to kinetic energy 500 electron volt. You have to convert electron volt to joule, multiply by 1.6 times 10 power negative 19, and from kinetic energy you can get the velocity. Kinetic energy is half mv squared. From velocity you can calculate the momentum. The momentum denoted by b, it is the mass multiplied by the velocity. The mass is given and the velocity calculated. De Broglie wavelength, it's lambda over the momentum. Kinetic energy equals 500 electron volt. We have to convert electron volt to joule. Remember that 1 electron volt equals 1.6 times 10 power negative 19 joule. So first of all, we write kinetic energy equals 500 multiply 1.6 multiply 10 power negative 19. The answer is 8.0 multiply 10 to the power negative 17 joule. The first part of the question, we need the velocity of that electron. The relation between kinetic energy and velocity is that kinetic energy equals half mv squared. So we write half m v squared equals 8.0 times 10 power negative 17. M, it is the mass of electron which is given. So the mass of electron, it's 9.1 multiply 10 to the power negative 31. Multiply v squared equals 8.0 times 10 power negative 17. From this, we calculate v squared divided this value by this. So it's 8.0 multiply 10 power negative 17 divided by half, multiply 9.1 times 10 power negative 31. By using the calculator, it becomes 1.76 multiply 10 power 14. Now, to get v, we take square root of the answer. So, square root of 1.76 times 10 power 14, square root equals, okay, here, 1.33 multiply 10 to the power 7 meter per second. Remember, this answer is acceptable because it's less than the speed of light. The speed of light, 3 times 10 power 8 meter per second, and this value is less than the speed of light, so it is acceptable. Part B, we need the momentum. The momentum denoted by B, which is m multiply v. M is the mass, v is the velocity. So the momentum equals m multiply v. So m is the mass of electron, which is given in the question. It's 9.1 multiply 10 power negative 31 multiply by the velocity of the electron, which is 1.33 multiply 10 power 7. The answer by using calculator, it's 1.21 multiply 10 to the power negative 23. The unit, it is unit of mass times unit of velocity, so it's a kilogram meter per second. The last part of the question, we need de Broglie wavelength. De Broglie wavelength, lambda equals h over b. H is Planck constant, b is the momentum. Planck constant, it is 6.63 multiply 10 to the power negative 34. The momentum is 1.21 multiply 10 power negative 23. The answer by using calculator is 5.49 multiply 10 power negative 11. It is wavelength, so it is in meter. Now you can solve exercise 10, Future in Physics book, number 2, 3, and 7. Question number 2, exercise 10 in Future in Physics book. The mass, which is 50 gram. We have to convert the mass to kilogram. So 50 gram equals 50 divided by 1000. So it becomes 5 multiply 10 to the power negative 2 kilogram. Okay, I have wavelength. So the given also is lambda, 3.32 times 10 to the power negative 34 meter. What is the speed? So the required is the speed. The relation that we can use is that lambda de Broglie wavelength equals h over mv. So we do cross multiplication to get the value of m, so to get the value of v. So from this relation we can say mv equals h over lambda. H is Planck constant, 6.63 times 10 power negative 34. Lambda is given 3.32 times 10 to the power negative 34. The answer by using the calculator, it is approximately equals to 2. Now we divide by the mass here to get, this is mv. So mv equals 2. So to get v, we divide by m. So v equals 2 divided by the mass. Now the mass is 5 multiplied by 10 to the power negative 2 The answer is 39.9. It's velocity, so the unit is meter per second. Question number 3. What is Dubrow wavelength? Of kilogram, okay, traveling at 43 kilometer per hour. So we have to convert kilometer per hour to meter per second. So the velocity, it's 43 kilometer per hour. To convert from kilometer per hour to meter per second, multiply by 5 over 18. So it's 43 multiplied by 5 over 18. So the answer is here approximately 11.9 meter per second. Dubrow wavelength, we can get it from the equation. Lambda equals h over mv. H is Planck constant, 6.63 multiply 10 power negative 34. M, it is the mass which is given, so it's 1375 multiply V, 11.9. So we can get the answer by using calculator. It becomes 4.04 multiply 10 power negative 38. It is lambda, it is wavelength, so the unit is meter. The question is kinetic energy equals 3 mega electron volt. It's better to convert to joule. So mega, it's 10 to the power 6, and electron volt to joule multiplied by 1.6 times 10 power negative 19. Then the answer in joule, it's 4.8 multiply 10 power negative 13 joule. Now we need a relation between kinetic energy and the momentum. Follow me, please. Kinetic energy equals a half mv squared. So we can write this as mv squared over 2. If we multiply by m up and down, so we multiply m and multiply by m down. So the answer is m times m, it's m squared v squared over 2m. We know that mv equals b, the momentum. So m squared v squared equals b squared. So the kinetic energy equals b squared over 2m. So this is the kinetic energy. So from this we can say b squared equals 2m multiplied by kinetic energy. So from this we can say b only equals a square root of 2m multiply kinetic energy. So this is the relation between the momentum b and the kinetic energy. Now what lambda Dubrow wavelength equals h over b. So it's equal h over a square root of 2m kinetic energy. H is Planck constant. M, we talk about electron. The mass of electron is 9.1 multiply 10 power negative 31 kilogram. So we do substitution. So lambda equals h, it's Planck constant, 6.63 times 10 power negative 34 divided by square root of 2 times m, the mass of electron, 9.1 times 10 power negative 31. Multiply the kinetic energy in joule, which is 4.8 multiply 10 power negative 13. The answer by using the calculator, it becomes 7.09 multiply 10 to the power negative 13 meters. So this is the value of lambda.